Hi everyone. In today's video, we're going to be talking about limit rules and methods of manipulating limits. The first method we're going to talk about is factoring. So we use the methods described in this video when we plug in our x value to the function, yet we get an indeterminate form. So I'll explain what I mean. Let's look at the example. Limit as x approaches 4 of x cubed minus 4x squared over x squared minus 16. Let's try plugging in x is equal to 4. The plug-in method is one method of solving for limits, which I talk about in my previous limits video. 4 cubed minus 4 times 4 squared over 4 squared minus 16. That actually gives you 0 over 0. And that is an indeterminate form. There are 7 indeterminate forms that usually come up with limits, and these are described in my blog post, which you can access at the link in the description below. So continuing from here, since we can't plug in the values without getting an indeterminate form, we're going to try something else. We are going to try factoring. So let's factor an x squared out of both terms in the top. Just pure guess, just factoring out the biggest value that I can from the top and bottom. X minus 4, and x squared minus 16 is a difference of squares, which is not covered in this video. But the way you would factor it is x minus 4 and x plus 4. So the bottom was factored using a difference of squares. The top is just common factoring. Now these will be able to cancel out. If I had only factored an x out of the top, I would still have x squared minus 4x left in the brackets, and I would not be able to cancel the top with anything on the bottom, which is why I didn't do this. Now simplifying it, we have x squared over x plus 4. Now we can try finding the limit. By plugging in x equal to 4. So the answer to this limit is 2, and all we did was common factor on the top and use a difference of squares factoring on the bottom to be able to get this factor of x minus 4 in the numerator and denominator and cancel them out to be left with x squared over x plus 4, and then we tried plugging in x equals 4 because it didn't work when we tried it the first time. Now let's look at the next method of manipulating equations. The next method we're going to be using is conjugate method. The example we're going to try here is the limit as x approaches 4 square root of x minus 2 over x minus 4. Well, our first plan is always to just plug in x equals 4 everywhere there's an x. So we would have the square root of 4 minus 2 over 4 minus 4. The square root of 4 is 2. 2 minus 2 over 4 minus 4 gives us 0 over 0. This is indeterminate. This is indeterminate form. So what we now have to do is try the conjugation method. So now that we've tried plugging in x equals 4, we know that that won't work because we get 0 over 0, and that is indeterminate. So what we are going to do is try multiplying by the conjugate. The conjugate is simply the opposite of the expression with the square root, which is either going to be in your numerator or denominator. To find the conjugate, all we're going to do is multiply by the opposite, square root of x plus 2. So all we do is switch the sign. And we write the same thing on the bottom. So it's essentially as if we are multiplying by a 1. So now let's multiply through on the top and the bottom. On the bottom, we just multiply through x minus 4, 4, square root of x plus 2. On the top, we will have to be distributing. On the top, we will have to distribute this times this, and this times this. And we will end up getting some terms canceling out, but I will just put them all here. We'll have the square root of x squared minus 4, so 2 squared, minus 2 times the square root of x plus 2 times the square root of x. These two terms cancel out. The squared and the square root cancel out, so on the top you have x minus 4. On the bottom we have x minus 4 over the square root of x plus 2. This and this is simply x minus 4, so they will also cancel, so you will be left with a 1. Now we are going to try taking the limit. Hopefully it works this time. So limit as x approaches 4, 1 over the square root of x plus 2. Now all we have to do is plug it in. Plug in x for equals 4 for every x in our function. Square root of 4 plus 2. And the square root of 4 is just 2. So our final answer is 1 over 2 plus 2, which is 1 over 4. And that is how we solve using conjugation. So that's all for today. In our next video, we will be going over using trig identities and squeeze theorem in order to solve limits that involve sine, cos, tan, or their inverses.